Okay, today we're doing Chapter 9, Rational Expressions, Section 9.4, Add and Subtract Rational Expressions. So adding and subtracting rational expressions, this works in the same as adding or subtracting fractions, in that we have to get the LCD for all rational expressions, and then add across the numerators once we've made each rational expression contain the LCD. So kind of like what we did in 9.3, we found an LCD and then we converted the rational expression, the original one, into the new one with a new LCD. And then finally, your LCD stays as the final common denominator. And once we've combined it into one rational expression, what we're going to have to do is we're going to have to factor that numerator and then see if anything will cancel out. So what we have, like denominators, if we basically have the same thing in a denominator, the c's in this case, then a over c plus or minus, depending on which way we're doing adding or subtracting, b over c is just going to be a plus or minus b all over that common denominator c. Now, if we have unlike denominators, say b and d, what we're going to have to do is we have to get a common denominator first. And so what that is, our common denominator in this case is going to be b times d. So that means we're going to have to take a times d over b times d plus or minus. Now here we have to multiply by b, so we're going to have b times c over b times d. And that gives us our AD plus or minus the BC over now our common denominator, the BD. So that's what's going to happen when we have unlike denominators. So that's probably going to be our most often cases. We have to do the common denominator, get a new numerator, and then add our numerators. And then if possible, we can reduce after factoring those. And so what we're going to do here is basically add or subtract the rational expression as given and then simplify completely. Well, looking at our first one, what do we have? Well, we have t minus 1 and t minus 1. Well, those are both the same denominator, so that means we can just add the numerators. When we do that, that gives us t squared plus 4t. Now we're doing plus, so it's going to be plus 2t minus 7 all over t minus 1. Now those two add together and we get t squared plus 6t minus 7 all over t minus 1. Now, can we factor this? Well, looks like the numerator is going to be t and t, 1 and 7. And if we take 7 minus 1, we get 6, so we need a positive 7 and a negative 1. That's all over t minus 1. And now here comes the simplify step. We're going to cancel out, and we're going to cancel out the t minus 1. And so when we do that, that gives us a final solution of t plus 7. Okay, so that's what this expression, two rational expressions added together, gives us our final step. And so that's why, once we added the numerators, we had to go ahead and factor and then cancel out what was common to both the numerator and the denominator. All right, so here we do not have a common denominator. We have 6r and we have 8r. Well, what is 6? Well, that's 2 times 3 times r. 8 is 2 times 2 times 2 times r. And so what we have to do is our LCD is going to be 2 times 2 times 2 times 3 times r. So that's going to be the whole thing. Was we have 3 here, we have 1 3, we have 3 2s I should say, 1 3 and 1 r. And so that's going to be our LCD. And so what we do is now rewrite this 5 over 6r, and maybe we should go ahead and write that as 2 times 3. That way we can see this a little easier. So that's 2 times 3 times r. So we have to multiply that by what? Well, we have the last 2, so we have to multiply that by 4 over 4. And we have minus 5 over 8. Well, let's do that 2 times 2 times 2 times r. And so here we have to multiply by 3 over 3. And so 5 times 4 is going to give us 20 over. And then 2 times 2 times 2 is 8, times 3 is 24. So that's actually 24r. Here we have 5 times 3 is 15 over 24r. Well, 20 minus 15 is 5 over 24r. And so that cannot be reduced because 24 has no factors of 5. And so this would be then our final answer. All right, first one here, it looks pretty easy. We just have a 2 and a 4 in the denominator. And so our LCD is actually going to be 4, because that's 2 times 2. And so what we have to do is we're going to have to multiply our first rational expression, a plus 2 over 2, times 2 over 2. Now then it's plus. Now this one we already have the same denominator, so we just have a minus 4 over 4. And so now we simplify. So we're going to have to distribute here. So that's going to give me 2a plus 4 over 4 plus a minus 4 over 4. And now I can just put everything in the numerator. We'll have 2a plus 4 plus a minus 4 all over 4. Well, looks like in our numerator, 4 minus 4 cancels, so that's gone. And so now I have 2a plus a, so that's 3a over 4. We can't simplify that any further, and so that will be our final answer. All right, so let's look at the next one here. Here we have a 2x squared y, and here we have an xy squared. So our LCD is going to be what? Well, we have to have a 2. We have 2 x's here, 1 here, so we have to have 2 here. We have 1y here, 2 here, so we have to have 2 here. So our LCD now is this value, 2x squared y squared. So now what we have to do is take 5x plus 3y over 2x squared y times what? Well, we have the 2 already, we have the x squared already, and we only have 1 y, so we're going to have to multiply this by y over y. Now in this one we have 3x plus 4y over xy squared. So what do we have to multiply this one by? Well, we have to multiply by a 2 and an x. So a 2x over 2x. And when we do that, that gives us a 2x squared y squared. This gives us a 2x squared y squared. So now we have to multiply on the numerator. So we're going to take the 5x plus 3y times y, which gives us, and remember, you're distributing, so you're going to take it times that one and that one. And here you're going to take this times this and this. So here we get 5xy plus 3y squared over 2x squared y squared. And then we have minus. Now we have 2 times 3, so that's going to give us 6x squared. And then plus, and that's going to give us 8y, or xy rather. That'd probably be the easiest way to write it. And then over the 2x squared y squared. All right, so now we have a common denominator, and now we just have to go and subtract across the top. So our numerator now 5xy plus 3y squared. Now we're subtracting the whole thing, so we have to remember to distribute not only this one, but also that one. And so it's going to be minus 6x squared minus 8xy all over our 2x squared y squared. Okay. So now what do we have? Well, we have 5xy minus 8xy, so those are going to reduce. And so, 5 of those take 5 of those, and we're left with 3. And now what we can do is say that this is 3y squared minus 6x squared, and then we have minus 3xy all over, and then we have 2x squared y squared. Now, here it looks like we have a 3 in common, so we could factor out that 3, but that 3 is not going to cancel the 2 here, so we're okay. Here we don't have an x, those places we have x's. Here we don't have a y, those places we have y, so there's no common terms in here other than that 3 we could pull out, and that's not going to help us cancel anything. And so then that will be our final value as far as the new rational expression. We could write it, rewritten it as 3y squared minus 3xy minus 6x squared, or whatever order we wanted to, but that would be our final value there. All right, couple more here. So the first one, we notice our first denominator is a difference of squares. So that's x plus 2, x minus 2. Here we have x plus 2, so we have a new LCD of x plus 2, x minus 2. And so we rewrite our two original rational expressions with our new LCD. And so our first one, guess what? It doesn't change. It's still a over x plus 2 times x minus 2. Then we have minus, and then we have 3 over x plus 2. But we have to multiply that by x minus 2 over x minus 2 to get that new LCD. So now we have 8 over x plus 2, x minus 2 minus, and then on the numerator we have to take and distribute here and here, so that's going to be a 3x minus 6 over x plus 2, x minus 2. Okay. Now we can go ahead and remember that distributes that negative on both of those, so we have 8 minus 3x, and a negative makes a positive 6 all over x plus 2, x minus 2. Now 8 plus 6, well, that's 14, and then we have minus 3x all over x plus 2, x minus 2. Now with this, there's not a common term in either one of those that we could pull out, and so therefore that's going to be our final answer. You know, there's you could rewrite it as minus 3x plus 14, and that's about the only other way we could change our final answer there. All right, so what about our next one? Well, it's going to be the same thing. We have to factor our denominators. Now, in the first one, we see that there's a 5x in common here, and if we pull that out, that's x plus 1. Now, the second one, we see there's a 3 in common there, and that's x plus 1. Okay. So now our LCD is going to be, well, we have x plus 1, and then we have a 5x, and we have a 3. So it looks like it's going to be 15x times x plus 1. Okay, now that's going to be our LCD. Again, we could have left it as 3 times a 5 if we wanted to, or 3 times 5 is 15, and we should be able to figure that out pretty quick as far as what we need to multiply or divide by. So let's rewrite our first rational expression, 2 over 5x, x plus 1. And what did we have to multiply by? Well, our LCD was 15x times x plus 1, so we had to multiply by 3 over 3. Now the second one, we're going to subtract. We have 4 over, and then we had 3 times x plus 1. And so what do we have to multiply by there? Well, we had to multiply by 5x over 5x. So that gave us 15x times x plus 1. That gave us 15x times x plus 1. So a numerator, 2 times 3, that's 6 over 15x times x plus 1, minus, here we have 4 times 5 is 20x over 15x times x plus 1. Now we can just subtract across the numerators, 6 minus 20x over, and then we have 15x and then times x plus 1. All right, well, is there any common terms here? Well, it looks like there's a 2 in common. Now, I don't know if that's going to help us. If we take out a 2, that's going to be a 3 minus 10x all over 15x times x plus 1. Nothing looks the same, so we really can't cancel anything. So, you know, this one is the fully factored form to show that we can't cancel, but again, this one is fine as well as far as your answer, unless it says specifically write in the factored form. All right, a couple more here. The first one, again, it looks like what we're going to have to do is we're going to have to factor both denominators. And so the first one looks like x plus 2, x plus 3, because we're going to have pluses on both of them, and 2 factors of 6 that add to 5 are 2 and 3. Now the second one is going to be similar. It's going to be x plus 2, x plus 1, because it's going to be the factors of 2 that add to 3. Well, that's 2 times 1, and 2 plus 1 is 3. And so our LCD is x plus 2, x plus 3, x plus 1. Okay. So what we have to do now is rewrite each of our factors with those new LCDs. And so that's going to be x over, and that was x plus 2, x plus 3, and then we have to multiply by what? Well, 2 and 3, so we have to multiply by x plus 1 over x plus 1, minus, now we have 2 over x plus 2, x plus 1, and we have to multiply that by what? Well, we have 2 and 1, so we have to multiply by x plus 3 over x plus 3. All right, so now we can distribute. We're going to take that x times each term, and here we're going to take that 2 times each term. So x times x is x squared, x times 1 is x, and then that's going to be over x plus 2, x plus 3, x plus 1, and then minus, now we have 2x plus 6 over, and then we have x plus 2, x plus 3, x plus 1. And now we can subtract across the numerator. So that gives us x squared plus x. Now remember that minus, you have to distribute to both of those. So that was x squared, and then that was an x, somehow got a 1 there. And that's going to be minus 2x, and then minus 6. And that's all over x plus 2, x plus 3, x plus 1. So what does that equal? Well, that's going to be x squared minus 6 over x plus 2, x plus 3, x plus 1. Now we have to think, can we factor this? 2 factors of 6, if we subtract them, give us 1. Well, yeah, that'll work. And if we do that, that's going to be x minus 3, x plus 2, because we'll have minus 3 plus 2, so it's going to be minus x, and that's going to give us a minus 6, all over x plus 2, x plus 3, x plus 1. Now, guess what? Our x plus 2 in the numerator and the denominator cancel, and so we just get x minus 3 over x plus 3, x plus 1. And again, we're going to leave that in factored form to show that there's no more terms that we can actually cancel out there. All right, a little more work, but still, again, it's just adding, subtracting in the numerators, and then being able to factor our denominators and then get the new LCD and converting our original rational expression into the new one with a common denominator. All right, what about this? Well, guess what? We just factored that down here. That's going to be our x minus 3, x plus 2. And this one is the difference of squares, which is x plus 3, x minus 3. So that gives us an LCD of x minus 3, x plus 2, x plus 3. So each one of them goes once. And so our new rational expressions are going to be 5x over x minus 3, x plus 2 times what? Well, we're going to have to multiply by x plus 3 over x plus 3. We're subtracting off now. And now we have 18 over x plus 3, x minus 3. And we're going to have to multiply by that x plus 2 over x plus 2. Now again, we have to distribute that 5x to both terms, and we'll have to distribute that 18 to both terms. So when we do that, 5x times x is going to give us 5x squared. 5x times 3 is going to be plus 15x, and that's all over x plus 3, x minus 3, x plus 2. Now minus, now that's going to give us on here 18x and then plus 36 all over x plus 3, x plus 2, x minus 3. Okay. Now remember, when we subtract, we have to subtract and change the sign of both of those. So that's going to give us a 5x squared plus 15x. Then we have minus 18x, then minus 36 all over x plus 2, x plus 3, x minus 3. Okay. Well, 15 minus 18 is going to be 3x. We'll have 5x squared minus 3x minus 36 all over x plus 2, x plus 3, x minus 3. Okay. Now we have to think if we can actually factor this one into anything. And so let's see here. We'll have a 5x and an x. And if we have 36, let's probably have a 3. It was going to be one of them. Let's try a 3, maybe a plus 3. Well, let's just have a 3, and then we'll have a 12. That's 15 minus 12 is 3, so we need a negative here and a plus here. So that gives us 5x squared plus 12x minus 15x is minus 3x minus 36. So that looks good. All over our x plus 3, x minus 3, x plus 2. Now, can we cancel anything? Well, x minus 3 cancel. And so then that gives us, for our final value, 5x plus 12 all over x plus 3, x plus 2. Okay. And again, I'm going to leave that in factored form. We can't do anything else with this. And so that's going to be our final answer. All right, couple more here. What about this one? Well, that's going to be x, and so two factors, 5 and 7 are 35, and so we'll have to have x minus 7, x plus 5. Now here we're going to have x plus 5, x plus 2, because they're going to both be positive, and so 5 plus 2 is 7, and so our LCD is x minus 7, x plus 5, x plus 2. So our first term, x plus 1 over x minus 7, x plus 5. Well, we have to multiply by x plus 2 over x plus 2. And then we're going to add to that. Now we have x plus 6 over x plus 5, x plus 2. And we're going to have to add in x minus 7. So we're going to multiply that by x minus 7 over x minus 7. And so what does that do? Well, we're going to have to distribute and FOIL, so that's going to give us x squared, and we have 2x plus 1x is plus 3x, and 1 times 2 is 2, all over our x plus 5, x plus 2, x minus 7, and plus, now we'll have x times x, so that's going to give us x squared, then we'll have minus 7 plus 6, that's going to be minus x, and then that's going to give us minus 42 over x plus 5, x plus 2, x minus 7. And these are adding, so we just go straight across and add. So we'll have x squared plus 3x plus 2 plus x squared minus x minus 42 all over our x plus 5, x plus 2, x minus 7. So now we've got x squared and x squared, so that's going to give us 2x squared. We have 3x minus x, so that's going to be plus 2x. And we have 2 minus 42, so it's going to be minus 40. Okay, and then that's all over our x plus 5, x plus 2, x minus 7. Now this, we can factor out a 2, and we have x squared plus x, and then minus 20. Now this can factor into x plus 5, x minus 4, because we need two factors of 20 that subtract to 1, which would give us that. And so it looks like at that point we can cancel. We have an x plus 5 and x plus 5. The 4, nope. The 2, nope. And so final answer is going to be 2 times x minus 4 over x plus 2, x minus 7. And so then that would be our final answer in the factored form, again, to show that we can't cancel anything out. All right, what do we have up here? Well, this looks like we have that 2's in the wrong place, the 2z. So if we take out a -1, that's going to give us 2z, and then that'll be -1, okay? And so that will give us something that looks a little more helpful, because this is a difference of squares, so that's 2z plus 1, 2z minus 1. So now we've got that, and then this one we have that. And so what I'm going to do is I'm going to kind of go ahead and say, well, let's take that negative, pull it up top, because it doesn't matter where the negatives can be in the denominator, it can be in the numerator, it can be out front. So I'm going to take it to the top. And so then I have LCD now is just 2z plus 1 times 2z minus 1. So if I have the initial one here is a -2z over 2z minus 1, I have to multiply that by 2z plus 1 over 2z plus 1. Then I have plus. Now I have 3z over 2z plus 1. So I'm going to have to multiply that one by 2z minus 1 over 2z minus 1 to get the common denominator. And then I just have -3 over, and then I have the 2z plus 1, 2z minus 1. Okay. So again, we're going to have to remember distribute here, and we're going to have to distribute here, and then we just subtract 3. So here we have a -2z squared. Oh, actually, that's 2 times 2, so that's a 4z squared. Then a -2z. Then we have plus, and then we have 2 times 3 is 6z squared. And then we have -3z. And then we have -3 all over our 2z plus 1, 2z minus 1. So now we have here 6z squared minus 4z squared is 2z squared. A -2 minus 3 is going to be a -5z. And then we have -3. And that's again all over 2z plus 1, 2z minus 1. All right, now can we factor this? That looks like it's going to be a 2z and a z. And 3, if we put a 3 here, that'll give us 6. And if we put the 1 here, and we need the -5, so that's going to be a negative, that's going to be a positive. So that's going to give us 2z squared and -6z plus z, so it's a -5z minus 3. So that looks good. And so now if we notice, we have a 2z plus 1 and a 2z plus 1 cancel. And that leaves us with a final value of z minus 3, z minus 3 all over 2z minus 1. Those can't be factored anymore, and so that then would be our final answer after we take and add those two rational expressions and then subtract off that one. All right, I'm going to stop the film here and do the last ones on another video.